Welcome. In this video, we will be taking a look at the fundamental trigonometric identities in chapter 10a. We're going to be working with reciprocal identities here on the left. Our reciprocal identities, just to remind ourselves of those, the cosecant, the secant, and the cotangent are all reciprocals of our fundamental sine, cosine, and tangent trigonometric functions. We'll also want to keep in mind the quotient identities, so that would be for the tangent. We can represent the tangent function in two ways. This would be the sine over cosine. That's the more traditional way to think about that identity. And we can also look at the secant over cosecant, another way we can flip those identities around. The cotangent identity is the reciprocal of our tangent, so we can just represent that as the cosine over the sine or the cosecant over the secant function. So all of those are important as we look through solving identities. The Pythagorean theorem identities are next in the bottom left. The Pythagorean theorem identity that you might have seen before is the sine squared plus cosine squared equals 1. So that'll be an important one that comes up quite often. We can rearrange this initial equation in two other ways using the tangent and secant functions and then the cotangent and cosecant functions. So each of those are going to be able to rearrange again, subtracting and adding for those functions themselves. And then the final thing we want to keep in mind are the odd and even identities. So the two trig functions that will be odd are the tangent and the sine. So sine and tangent are both odd, meaning when we take their negative x angle, they will be the opposite negative sine x and negative tangent x for both of those. And we can consider cosine as an even function because when we take cosine of negative x, it just gives us back cosine of x. So cosine and therefore secant are going to be even, and then our sine cosecant, and then the tangent cotangent are both odd functions. And then we're going to take a look next at a few examples to get us started. And when we think about simplifying trigonometric expressions here to one single trigonometric function, there's a few strategies that we can take, and we'll display most of these together. We can think about converting terms to cosines and sines and seeing where the identities lead us. We can look for opportunities to factor expressions, again, then getting into sines and cosines if we can, and also operations like addition and subtraction are going to be helpful as well when we try to find common denominators with fractions and splitting up single expressions to sum and differences will be helpful. So we'll take a look at using all of those techniques in this video. So let's take a look at number 1. We have the cotangent x divided by the cosecant theta minus sine of theta. So all of those are theta. I think I said x, but all in terms of theta. So let's think about the definitions for each of these functions and see where we can work these. So I know that the cotangent is the same as the cosine of theta over the sine of theta. And then I can work with the rest of the functions. The cosecant of theta is the same as 1 over the sine of theta. And then we'll say minus sine of theta. All right, So we have them in terms of sines and cosines, and now I want to consider simplifying this complex fraction. I'm going to start here in the denominator. So in this denominator, I can look to add these two by multiplying to get a common denominator. If I wanted a common denominator, the sine of theta, I can multiply the numerator and denominator by sine theta. So that would be sine of theta. And then if I multiply sine of theta in the numerator, that would just be sine of theta squared. So let's consider what we have now. We have overall the cosine of theta divided by sine of theta. And then divide by, we'll have 1 minus the sine squared theta all over sine theta. All right, so we have, again, a complex fraction with a fraction in the numerator and in the denominator. One thing I can consider now is to flip this fraction in the denominator and multiply it with the one in the numerator. So we can take this expression with the cosine theta over sine theta and multiply by sine theta over 1 minus sine squared theta. So flipping and multiplying. We'll see right away that we can cancel out some sine thetas here. Those will cancel out to 1. And then the last thing we can notice is 1 minus sine squared theta, this portion right here, this we can represent with the Pythagorean theorem identity. So remember, we have that sine squared theta plus cosine squared theta is equal to 1. So we can use that fact to see if we can identify what 1 minus sine squared theta is. So if I did 1 minus sine squared, that's really just subtracting sine squared theta on both sides. We would say that's just going to be cosine squared theta equal to 1 minus sine squared theta. So this identity we can actually replace with cosine squared. So we'll do that. We have cosine theta divided by cosine squared theta, which we can simplify down to a single expression. This will be 1 over cosine theta, or we can just represent this as secant of theta. So that's the single trigonometric function that we would end with, secant of theta. All right. So in the next video, we'll take a look at the next few examples here. Again, as we go through these videos, you can stop this video at any time and take a look at those steps individually. So thanks for watching.